Alright, Chapter 3, Alignment of the Railway Lines. Alignment of the railway lines refer to the direction position given to the entry of the line railway track with the ground with the horizontal and vertical planes. Horizontal alignment means of the direction of the railway track with the plane, including the straight path of the curve that follows the vertical alignment means the direction of the flow follows the vertical plane, including level of the track gradients of vertical curves. The various factors affecting alignment of the track alignments of their suitability to different terrains are discussed in this chapter. 3.1. Importance of the good alignment. The new railway line should be aligned with a carefully held proper consideration. Proper alignment of the line of all ultimately proved to be more costly and may not be able to fulfill the desired object. The railway line construction capital intensive. The project once constructed is very difficult to change the alignment of the railway because of the cost of the structure involved with the difficulty of getting and adding the land of the new alignment, such other consideration. 3.2. Basic requirements of the ideal alignment. The ideal alignment of the railway line must be meet the following requirements. Perfect the new railway line. The alignment of the new railway alignment should serve the purpose for which the railway line is constructed. As brought out earlier, the purpose may include the strategic consideration, political consideration, developing backward areas, connecting the new trade center of the shortening existing rail lines. Integrative development. The new railway line should fit with the general planning of the form of the part of the integrative development of the country. Economic consideration. The construction of the railway should be economical possible for the following aspects required with special attention. Shortest route. It is desirable to have the shortest route, most direct route between the connection point of the shorter length of the railway line, lower cost of the construction, maintenance, operation. Then can, however, be other practical consideration that can lead to deviation of shortest route. The construction maintenance cost of the alignment of the line should be shown for the construction cost is minimum that can achieve the balance cost with the available of the earthwork minimum rock cutting of the drainage costing of the locating drainage costing locating alignment with the watershed and such other technical consideration maintenance cost for the reduced avoiding the steep grades for the sharp curves and cost for the heavy wear of the tear of the rail for the rolling stock. Minimum operational expense. The alignment should be such that the operational transportation expense are minimum. This could be done by maximizing haulage goods, but giving them the more power of the locomotive and traction. Make sure this could be achieved with providing easy gradients, avoiding sharp curves, and adopting direct route. Maximum safety control. The alignment should be such that the proper provided the maximum safety conformity with the traveling public. This should achieve with the design of the curve of the proper transitions, length of the provided with the vertical curve of the gradients, incorporating such of the technical features, aesthetic considerations. When designing alignment, this aesthetic aspect should be given the weightage of the journey of the rail, which should be visually pleasing. They should be done with avoiding the views of the borrow pits, placing alignment through the natural, beautiful surrounding with the scenic property. 3.3. Section of the good alignment. Normally, a direct straight route with the connecting 2 points is short of the most economical route of the railway line. But there are practical problems other than the compulsion of the necessity deviation from this route. The various factors involved in selecting with a good alignment of the railway are given below. The choice for the gauge. This gauge, the gauge can be broad gauge, meter gauge, or even the narrow gauge as the least as per the lease policy for the government. Any of the new railway lines are constructed with a broader gauge. The various gauge that has been discussed in Chapter 2. Obligatory controlling points. This point throughout the way of which the railway line has passed due to political, strategic, commercial, rural reasons, as well as due to technical consideration following the obligatory and controlling points. Important cities and towns. The most intermediate important towns and cities in place with the commercial, strategic, political importance. Major bridge in sight on the river crossing the construction. Major bridges with the large rivers is very expensive. Suitable bridges sites becoming the obligatory for a good alignment. Existing passes and saddles in a hilly terrain. Existing passes and saddles should be identified crossing a hilly terrain to avoid deep cuts in the high banks. Sites for tunnel. The operation of the tunnel of the police of the deep cut and highly terrain with a better with the economical viewpoint. The exact of the size of the tunnel becomes an obligatory point. Topographically of the country. But the alignment of the new rail lines depends on the topographic of the country and the traverse for the following few situations as this may arise. Plane alignment. The topographically plain and flat line of the alignment presents no problem that can carve through the obligation point for they are easy gradients. Very alignment. The alignment of the railway line valley is simply and does not pose any of the problems. The control line points lie in the same valley as straight line with the provided between these points of the uniform gradient. Cross-country alignment. The alignment of the railway line is such that the terrain for the watershed with the two or more sides streams vary side with the lead of the very ends. The cross-country with the gradient steep at the very for the they see. If they are sagging some minutes, the controlling obligatory of the controlling alignment may be the lowest. The saddles and tunnels may be desirable alignment with some length of the watershed. Some of the drainage crossing may be avoided. Mountain alignment. The level of the main mountains vary considerably. If normal, the alignment is adopted, the grades would become steeper. There's much more than the ruling gradient, allowing the gradient. In order to remain the ruling gradient, the length of the rail line is increased artificially by the developing process. This follows the following are the standard method of developing technique. The zigzag line method is a method of railway line transversing the zigzag alignment that involves the conventional side slope, which rarely, nearly right angles to the general direction of the alignment. The line then turns about 180 degrees in a horseshoe pattern to gain height. Switchback method. In case of the steep side slope, the considerable gain of the elevation accomplished with the switchback method. The method involved the reversal direction achieved by a switch, for which the train has no necessary stopping. The switch point is normally located in the station yard. Figure 3, 2A and B are two switches A1 and B1 are the two buffer stops. Train coming from D will stop at B1 and move back in the gear to line BA and will stop at A and again to follow BA. Follow the line AC. This is your zigzag alignment. You're switching back. Like I said, it says you have two switches, A1 and B1. And what they do is the train coming from D will stop at B1, and then move back to the gear BA. So BA, it will stop at B1, coming from B1B to A, and then A to C. Alright, your spiral complete to loop method. The method is narrow valley with a small bridge with the viaduct that has been constructed with considerable height of the span of the valley. In this case, the normal complete loop of the railway line is constructed so that the line crosses the same point the second time the height of the fly over the tunnel. Track, bridge, and river, tunnel. Commercial geometrical standards. Geometrical standards should be adopted so that the economized as much as possible as well to provide safety and comfort of the passenger. This can be done with adopting gradient of the curve without within permissible limit. The transition as well as the vertical curve should be used to provide better comfort and safety. Geological formation alignment should be selected that it normally runs on the good and stable soil with the formation as far as possible. Weak oil and marshy land present the number of the problems, including those of the maintenance. Though rocky soil provides a stable formation. It is a costly proposal. Affecting flood climate. The alignment should be normally path for the area of which are not likely to flood, but the climate conditions show that should be also taken with consideration for the alignment. In the hot climate, the sandy area, the alignment should be passed by those sides of the sand dunes and with the face of the way the direction of the wind. Similar to the gold region of the alignment, should pass for those of the side of the hills and the face away from the direction of the wind. The sunny side is the most desirable. Position of the roadway and roadway crossing. Rail lines should cross the road at the right angle so that they have a perpendicular level crossing and avoid accidents. Proximity and labor material. Availability, the proximity of local labor and the good and cheap of the building materials should also be considered with the deciding of the alignment. Location of railway stations yard. Railway station yard should be located with level stretches of the land, preferably with the outskirts of the town, village, so that they have enough area to free flow with the traffic, religious and historical moments. The alignment should be avoided with the religion and historical moment that is normally not possible to dismantle these buildings. Cost consideration. Alignment should be such so that the cost of construction of the railway line is as low as possible. Not only the initial cost of the construction, but also the maintenance cost should be as low as possible. For the purpose of the alignment should be as straight as possible. For the least work with it should be through the terrain of this good soil. Traffic consideration. Alignment should be selected with that it attracts maximum traffic in town tanks for the traffic center that should be well planned. Fill up the railway line is patronized with the gross of the reviewing the rising of the traffic receipts as high as possible. Economic consideration. Keep in mind the various conditions that should be ensured that the alignment is over the economical for the purpose of the various alternating alignments. Consider the most economical one which if the cost effective gives the maximum return in the chosen. Maximum annual return Y is calculated by the formula Y equals R with the gross revenue earned by the railway line, and E denotes the annual running expense. It is to be noted that here the art is upon the route to provide the advantage when the track of the consideration therefore should be given the due weightage of the way the maximum annual return of the sound economical construction work to reduce the annual response expense. A suitable balance has been achieved between the construction costs and operating expenses. Political consideration. The alignment should be taken into account, but the political consideration should not enter the foreign soil should there be preferably to be any way from the common border areas. 3.4 Mountain Railway. There are a few hills and mountains that have been connected with the railway line. Some of the important features of the mountain railways are following. The gradients of the Guardian Mountain track are very steep, and the normal tracks are gradients for 3%, and the more the conservative mountain tracks. Gauge normally narrow within the gauge of the 762 millimeters or 610 millimeters are adapted to the mountain railways. Curvature of the mountain track is very sharp. The curvature is up to 40 degrees in the normal adapted alignment. Most alignment is quite zigzag and straight in order to be high easily with the type of alignment normally followed with the zigzag switchback or in spiral. Purpose: the main mountain railways have been constructed for the tourist traffic that commence in some cases the construction for the exploiting of the hindered land and new areas. Cost construction of the mountain railway than the tie because of the need for the large number of the bridges, the heavy earthwork, the cost of the output greatly and considerable reducing the output of the smaller gauge and narrow gauge. Then it is possible to have this very steep gradients sharp of the curvature. Some of the important mountain railways existing in India today are the Kalak Shimal Railway, the Algeria Mountain Railway, the Manthurian Railway, the Darjeeling Himalayan Railway, Kangra Valley Railway, and the Hadinium Kathagadium Railway. 3.5 rack railways. In case of the very steep, the gradient is much steeper than 3%. Most of the difficult locomotives to pull the train, although it has the depends pump, the train slide down and slid back along with the ground grade. The rail track of the rack railway consists of 3 rails and one extra tooth railway in the middle of the additional of the 2 normal rails. The locomotive also has a tooth pinion wheel whose teeth fit into the groove with a certain central tooth rail. This locking arrangement helps to hold the train load and does not let the locomotive slip back. And these various such systems exist in the Indian Railways, such as Falve system, Abbott system, the Riggenbach system, the Marsh system, and each of which is own characteristic. With the help of this rack pinion, it is possible to move the train even on very steep gradients such as 1 and 5. Alright, summary. The alignment of the railway line is extremely important for the subsequent cost of construction operations, depending on heavily on it. The basic requirements of the factors affecting the alignment that have been discussed in this chapter. The various types of engineering surveys required to mark the alignment of the railway line are described in the next chapter. Chapter 4, Engineering Surveys, Constructions, and New Lines.